Good afternoon, ladies and gentlemen. Welcome to the Rochester Security Summit 2024. Just a quick reminder, please silence your phones if you haven't done so already. Um, I would also like to thank our various vendors who have helped make this event a splendid affair. Um, Axionis, especially in our room. And now let us get started. I'd like to introduce to you Matt Gracie. He'll be talking about building a sawmill with Security Onion. And with that, let us proceed.
Thanks so much. Everybody can hear me okay? We good? All right. I have silenced my phone. I'll put that down. As Lillian said, the title of my talk is Building a Sawmill, Processing Logs with Security Onion. So as always, I will start with the two most pressing questions. Who am I and what am I talking about? I do see some familiar faces. For those of you who I don't know, my name is Matt Gracie. I work for a company called Security Onion Solutions. Has anyone heard of Security Onion before? Does that sound familiar? Okay, a few people. Right here at the beginning, I like to draw a distinction. Actually, two things. One, don't feel like you have to take notes or take photos of the slides. They're all up on my GitHub, and there's a link at the end of the presentation, so you can pull a copy down. But the other thing I want to mention is Security Onion is a free and open platform for network monitoring. We're going to talk about some use cases for it today. Security Onion Solutions, which is the name of my employer, offers commercial support for that. So this is not in any way a sales pitch. I'm not telling you about any commercial products. I don't even want your email address. You can go to our GitHub and download Security Onion, play around with it, do all the stuff that I'm going to show you today without ever talking to me again. So just want to get that clear up front. I know the names are similar, so people think it's some kind of, subterfuge, but I assure you it's not. So anyway, I work for Security Onion Solutions. I do support and pro services for the Security Onion platform. Before that, I was a blue teamer for about 15 years. I worked in a bunch of different industries. I worked in higher education. I worked in manufacturing. I worked in healthcare. So I've got a lot of experience on the defensive security side of things. Additionally, I am an adjunct professor at Canisius University in Buffalo, New York. Canisius started a graduate program in cybersecurity in 2020. I joined the faculty in 2021, and I teach their courses on blue teaming and red teaming. I actually use Security Onion as part of the curriculum in my blue teaming course. And finally, I also organize a bunch of community stuff in Buffalo. So I organize InfoSec 716, which is a monthly meetup for security hobbyists and practitioners. I also organize the B-Sides Conference in Buffalo. So if you're in the area and any of that stuff seems interesting to you, please feel free to find me on Twitter or come talk to me. I'm easy to pick out of a crowd, so if you have questions, just find me. So enough about me. What am I talking about? Well, this is our goal. So you may have seen pictures of this style of architecture before. This is called a panopticon. And the idea is you want to have one central location in a building from which you can see everything that's happening in an environment, right? As defenders, this is what I want to talk about building. In your environment, in your enterprise environment, you have systems everywhere that are producing all kinds of interesting logs, interesting facts, interesting data about what's happening on your network, in your environment, with your users, with your accounts. Our goal is to build that tower in the middle, right? We want to have one vantage point where we can ingest all of this information, pull it all into one place, and then use it to get a holistic view of our environment for monitoring, for enterprise operational uptime stuff, for alerting, for detection, for investigation, right? So that's what I'm going to talk about today, how we can use this free and open platform to take the logs that you're already generating in your environment and get greater visibility into what's happening on your network. For the sake of clarity, you're there. That's where you're supposed to be, in the tower there. All right, so what sorts of logs do you generally see in an enterprise? If you're using a lot of Windows machines, and most enterprises do, you're generating a fair amount of Windows logs. You've got the classic system security application logs. You've got telemetry logs. You may have things like Sysmon, PowerShell, Defender, all that stuff. all being written to local disks on all of these Windows devices throughout your enterprise, whether they're servers or workstations or the Windows phone that somebody forgot in a drawer. They're all generating logs. We want to be able to take all of that information and put it into one place so that we can use it to investigate. If your enterprise uses Linux machines, right, either as desktops or servers, I'm told this is the year of the Linux desktop, you want to be able to pull those logs off as well, right? Off your web servers, off your load balancers, off all of your infrastructure stuff, authentication logs, that sort of thing. Your Linux boxes have all of this stuff, and again, it's all being written to the local drives. We just need a way to pull it in and normalize it. Same thing for Mac OS. It's basically the same functionality as Linux, just broken, so it does the same sort of thing. It generates the same kind of logs. We can pull those off. If you have network devices in your environment, and again, if you're an enterprise of any size, you do. You've got things like load balancers, you've got firewalls, right? NAT gateways. Those all generate logs. Those logs can be normalized and ingested as well. If you have cloud services, so if you're running part of your infrastructure in Azure or AWS, or if you're IBM Cloud's customer, I'd like to meet you. Those all produce logs as well, and most of those can be pulled in via API, normalized, digested using the same techniques that I'm going to talk about for the on-prem logs, right? And finally, for endpoint agents, if you have something in your environment like CrowdStrike or Carbon Black, right? In many cases, those vendors will offer you access to their logging infrastructure. CrowdStrike has a functionality they call the fire hose, where basically all of the telemetry that those CrowdStrike agents are collecting in your environment, you're able to leverage. You can pull them in and ingest them into a platform of your choosing. This is helpful for a couple reasons. One, because it allows you to pivot from other log sources into those CrowdStrike logs, and partially because it allows you to attain greater retention, right? If CrowdStrike's only giving you 7 days of retention, but you need more than that, you can put them into your own system, save them for longer. All right. I clearly did not think this through. Give me just one moment. Okay, thank you. So we've got all of these different log types floating around in our enterprise, right? How do we gather them? Well, in a security onion deployment like I'm talking about here, from the endpoints, we can do a local installation of the Elastic Agent. The Elastic Agent is an endpoint agent. It's available for Windows, Linux, and Mac OS clients. Mac OS supports both CPU architectures, and it can be deployed to the endpoints in your environment and used to gather log information that they're already generating. So if you have Windows logs, security logs, system logs, application logs that are being written to the local disk, you can tell the Elastic Agent, pick those logs up, forward them into my security onion deployment. The big advantage here is this is all centrally controlled. So once the agent is on the endpoint, if you need to update what logs it's collecting or if you need to change retention, anything like that, you can do all that from a central point. On the network side of things, generally you're going to be gathering these logs using syslog ingestion. So we leverage Elastic integrations, which are built-in parsers and ingest pipelines developed by Elastic. So you can just point your device at your security onion box and say, hey, I've got a bunch of Palo Alto logs. They're going to be coming in on port 9002. Send those down the correct ingest pipeline, and it'll do it. It'll tokenize everything, normalize it all for you. Cloud services, again, this is more of a pull than a push. So if you've got logs up in AWS, a CloudTrail log sitting in an S3 bucket, all you do is provide the access key, the secret key, and it reaches out, pulls those in, and parses them accordingly. Okay. So however you're generating these logs and however you're transmitting these logs, the end result is the same. They all end up going into these ingestion pipelines in Security Onion, which I'll talk about in just a moment. So I've been saying Security Onion a lot. This blurb is off of our website. Security Onion is a free and open platform built by defenders for defenders, and I will absolutely stand by that as true. Pretty much everyone in the company is an ex-blue teamer, so we build all these tools because we know what's useful and we know what will help. It includes network visibility, host visibility, honeypots, log management, and case management. Now, I know it was subtle, but you may have picked up on what I'm going to emphasize in the rest of this talk. People tend to think of Security Onion primarily as a network monitoring platform, which it is, and that's really what its roots are. But we realize that as more and more traffic is encrypted and as it's harder and harder to get useful intelligence out of network traffic, it's very helpful for us to be able to ingest different logs to give you other views into that traffic. And we'll see that in a little bit. The main components of Security Onion are pretty straightforward. There's a management component, and that is the web interface for your deployment, where you do your investigation, where you do your configuration. There is what we call the search, which is an Elasticsearch instance that's part of the Security Onion stack. That's where you do your data ingestion. That's where you do your data lifecycling. So if you have hot data to warm to cold, or if you want to retain, this set of logs for 30 days, but this set of logs for 45 days, et cetera, all that functionality falls under the search. And then finally, you have the piece that people generally think of when they hear Security Onion, which is the sensor, right? Doing full packet capture, doing IDS, doing network metadata generation using something like Zeek. So these functions all exist as parts of Security Onion. If you've played around with Security Onion at home or in a small environment, you've probably used what we call a standalone deployment, where we have all three of these components and we put them all on one box, right? And they all run. So you've got a second network card on your old hand-me-down desktop that's hooked up to a TAP or a span port. That's running the sensor piece. Everything's being logged and then ingested into the search piece, and you're accessing everything through the web management piece. These components are distinct from one another. They can run all on one box, like here, or they can be kind of chopped up and moved around depending on what sort of data you're ingesting, what kind of hardware you have available, what kind of performance limitations you run into, etc. The particular architecture I'm talking about today is what we call a manager search. So there's no sensor capability, right? And when we get to the demo, I will emphasize that again. But what I'm talking about is a deployment that features only the management and search portions of the architecture. You've got the web interface, you've got the ingestion and the database piece, but that's all. We're not generating any of these logs in Security Onion proper. Instead, we're generating them on external systems and ingesting them into Security Onion for use, right? So even if your environment doesn't have taps or doesn't have span ports, and doesn't have anywhere for you to plug in, you're still able to ingest all of these logs and take advantage of them using this tool set. So the ingestion flow for these logs is pretty straightforward. We start with the log source, whatever it may be, and whatever the transport may be. It may be a file written to a local machine. It may be packets coming in via syslog. It may be stored in an S3 bucket or in whatever other cloud providers call an S3 bucket. I'm sorry, I've mostly just done AWS. But in any case, it's a log, it's a piece of information generated in your environment that you want to ingest, right? We take that piece of information, we capture it using the Elastic agent, either by reading a local file, by receiving it over UDP, by reaching out, making an API call to retrieve it. Whatever we do, the Elastic agent is involved. The Elastic agent then sends it to a Logstash receiver, which is a daemon that's listening in the Security Onion environment. We do support multiple receivers in more complicated deployments. In this case, there's just one running on that manager search that I mentioned. And then finally, the Logstash receiver sends it into Elasticsearch where it is parsed and put into the backing database. So for a Windows endpoint, for example, right? Say we've got a standard issue employee laptop that we want to gather some logs from. So we would install the Elastic agent on that Windows endpoint. The Elastic Agent would be configured to retrieve certain logs, maybe Sysmon if you have that in your environment, maybe PowerShell, Defender, all the basics, application, system, security. The Elastic Agent is also capable of generating what we call Elastic Defend, which is endpoint telemetry information, things like registry keys being touched, files being created. We'll see that a little bit in the demo. It marshals all this information up. It sends it into the Logstash receiver. The Logstash receiver sends it to the Elasticsearch database, and everything gets stored on the back end for us. Now, you may be thinking, I have all this information coming from different sources. I'm pulling information from my Linux clients. I'm pulling information from my Windows clients. I'm pulling information from my Palo Alto firewall. I'm pulling information from all of my Fortinet appliances, patch those. I have all of this stuff coming in that I really want to be able to normalize. How do I do that? Well, as part of our product, we use what's called the Elastic Common Schema. The Elastic Common Schema, again, open source specification. You can look at this on Elastic's GitHub site. But this is a database schema that is designed for this use case, for this network and endpoint log use case, where every piece of data is given a particular name and a particular type. Now, why is that important? That's important because you may be digesting data from a endpoint that calls a source IP source.ip. And you may be ingesting data from a load balancer that calls it source_IP. And you may be ingesting it from a firewall that calls it src.ip. And you may be cursing the developers of Zeek who call it ID_originating host, right? Everybody has slightly different names for this stuff. As part of the ingestion process in Elasticsearch, we normalize all of that and we convert it all to Elastic Common Schema. So that means when I go into the web interface and I say, hey, what logs do I have for source IP 192.168.10.10? It's going to look across all of those different data sets and identify the proper field with the source IP in it across all of them and present it all in one holistic view, right? This is a huge leap forward for sanitizing your data and making it useful, because now you don't have to remember, oh, right, the firewall in that location is running an old version of Palo Alto's operating system that calls the source IP something else, right? Or, oh no, I'm using pfSense over here and it's defining things slightly differently. No. Once it hits the database, once it goes through the ingestion pipeline, everything is named the same. Everything is stackable, right? So as an analyst, that makes it a lot easier for us to do investigation, because now we can pivot from one data source to another without worrying about where it came from, all right? So that's one sort of unifying standard that we leverage. Another one is Community ID. Has anyone heard of Community ID before? I believe this standard came from our friends at Corelight who are right outside the door there. No? All right. This is awesome. This is going to blow your mind. Okay. So the idea behind Community ID is that we can take any piece of log information that has a source IP, a source port, a destination IP, a destination port, and a transport protocol. That is, it's either TCP or UDP, right? So 5 tuple, 5 pieces of information. We take those 5 pieces of information, we put them all together, and we hash it. Now, what does that mean practically speaking? Because the source port is most likely unique, even if it's a fairly busy server, that means that that hash can serve as a fingerprint for that network connection, right? If I'm connecting to this web server, my source IP might get reused. My destination IP is going to get reused if it's a server. Port 80 is going to get reused, but it's going to be a random ephemeral source port, right? So that particular network flow, that particular transaction is going to be uniquely identified by this Community ID hash. Does that make sense so far? Now, the really cool thing is that we put processors into that Elasticsearch ingestion pipeline that generate a Community ID for, I'm not supposed to say every, almost every piece of network information that comes through. So if you're ingesting data from firewall logs, if you're ingesting data from a load balancer, if you're ingesting data from an endpoint, if you're ingesting data from a cloud service, anything that has that 5-tuple, source, destination, TCP or UDP, right, is going to get a community ID assigned to it. That means that I can look for that community ID, and it will give me the ability to pivot between completely different data sets that are all related to the same flow. I can go from a snort alert to Zeek metadata to endpoint logs generated by Elastic Agent to metadata generated by Suricata, because they all have that same community ID in them, right? Super, super cool. I'll show you in the demo in just a second how neat it is. All right, so I've ingested the logs. Now what? I've built this whole infrastructure. I'm pulling all the logs in. What kind of tooling do we have in our platform to allow you to take advantage of that? Well, this, and I apologize, I should have done these in light mode, but it looks so much cooler this way. This is our alerts panel. The alerts here were all generated in the demo environment that I'm going to show you in a minute, external to Security Onion itself. These are logs that were submitted from an outside Suricata instance of Suricata alerts, and we were able to pick those out of the log data and present them as alerts to an analyst. If you have devices in your network that have IDS capabilities or have some other kind of network alerting capabilities, you can do this same thing. Point them at the Security Onion box, configure it to recognize the traffic so that it knows what's an alert and what's not, and it can present them to your analyst as a work queue, just like this, right? We also have our dashboard component. Dashboards is a set of visualizations and tables that we include as part of the platform. They're all customizable. You can tweak them however you want. You can make your own. They are included for pretty much any IT protocol you can think of. So DNS, HTTP, any of that stuff that we can capture with our sensors. There's also, if you're in the OT or SCADA world, there's capabilities built around that too. But this particular one is an endpoint log dashboard. So it's showing me in my environment which usernames are executing things on which hosts, what working directories, what is running, what is the process status, etc. So there's a ton of information that we could pull out of that Elastic Agent on the back end. Or again, if you're using a different endpoint agent, we may be able to integrate that as well. This is our hunt screen, so this is for more kind of chopping and slicing and dicing the data as it comes in. As you can see, we've got a bunch of different event modules and then event data sets within those modules. We'll dig into that more in a moment when we get to the demo piece. And then finally, we support log analysis and alerting via Sigma. Is anyone familiar with the Sigma language? Does that sound familiar? Okay. If I can step back into story mode for just a moment. Somebody realized that every time there's a new threat or a new IOC or something new that we need to detect, we all had to go off in our own little directions and write detections for it, right? The guy running QRadar had to write a QRadar one. The guy in Sentinel had to write one in KQL. Whoever's in Splunk had to write one in the Splunk query language, et cetera, right? It was a lot of duplication of effort. It was a lot of potentially mismatched detection syntax because you didn't really have a guarantee that everybody was detecting the same thing the same way, right? So Sigma was developed as kind of a meta language for doing pattern matching in log files, essentially. So you could write a Sigma rule once, and it would be compiled for the appropriate destination system. In our case, Elasticsearch. If you're running Sentinel, you can do it in there. If you're running Splunk, you can do it in there. If you're running QRadar, I'm sorry. So, but the idea is that you had a language to write these detections in, and then they would be automatically run against your logs every so often. In this case, this is a pretty simple detection. It's saying, hey, if you see a PowerShell script, and you're running script block logging, obviously, and the script contains clear history, or if the script contains remove item, or if the script contains console host history.txt, that's all very suspicious, right? So in this case, somebody's probably trying to clear their console history. We should alert on that because it may be somebody trying to cover their tracks, either an adversary or an internal threat. So when you turn on a rule like this, what it will do is it will run the associated Elasticsearch query against the logs that you've collected every 3 minutes. And if there's a match, it'll raise an alert for your analysts. Now, I know that sounds like a very simple capability, but if you think about it, that's very, very powerful. That means any log that I'm collecting from anywhere on my network has now become a detection opportunity. If I have an IOC that I want to find, if I have a hash that I want to spot, if I have anything happening on an endpoint that should immediately, raise my radar, somebody accessing the LSAS process, right, something like that, then I can write a rule around it that will immediately alert. And again, we're doing all of this with just logs that you're already generating in your environment. We're just collecting them in one place so that we can write detections against them. It's simple, but it's deceptively powerful. All right, so you get the idea, right? We're pulling in all these logs from all over your network. We're normalizing them. We're putting them in one place. We're able to use them for investigation. We're able to use them for detection, analysis. Let's see what it looks like in practice. So this demonstration environment is very simple. We have essentially 3 boxes involved. There is a Security Onion VM. That's the one at the top there. Graphic design is my passion. And that's absorbing the logs from the other 2. It's not doing any active network observation. None of that sensor functionality is involved. This is a plain Jane manager search node. That's all it's doing, right? We have a Windows 10 VM that is generating some traffic, and then we have a pfSense firewall. Those of you who have not heard of pfSense before, it's an open source firewall product, very similar functionality to any firewall you might have in your environment, something like a Palo Alto or a FortiGate or whatever. The big advantage for me doing this on a demonstration is I can install a VM of this for free. So again, we have a Windows host that is generating traffic, that's doing IP stuff. We have a pfSense host that is at the border of this virtual network, and they're both sending their logs up to the Security Onion box. So this will give us a chance to take a look at how the Security Onion console actually works, some of the capability that's built into it, and how we can pivot between these different data types. All right, so I'm going to put the microphone down for a moment and start up the video. Just a sec. Okay, so this is what we call the overview screen. This is sort of the main interface. All the different components are along the left-hand side of the screen there. I apologize. This is a couple versions behind. We have some cool new features that we just released this week. I'll talk about those after the video, but I'm already behind. Okay. So this is dashboards. As I mentioned, this is all of the built-in tables and visualizations that are being built with this log data that we're ingesting. Over on the right there, we've got a time selector. So we're looking at the last 24 days because, again, this is a demo environment. It's not generating a ton of traffic. Scrolling down, you see tables for host name, source IP, destination port, etc. And you can see we've got a bunch of different event modules here. We're pulling in data from systems, from endpoints. Right now, I've just added pfSense to the query, so we're adding pfSense as the module. You can see we've got some authentication events there, and then we've also got some network events in the category on the left there. So these traffic flow logs are all generated by the firewall. This is not anything that Security Onion is natively observing. but rather it's ingesting that data and normalizing it so it just looks like normal Security Onion data. So we're on destination port 80. Oh, now we're off destination port 80. Kind of can't wait to see what I do next. The source IPs here, we can concentrate on just a particular source IP. And you see on the event module over on the right there, I've got endpoint logs and pfSense logs. So I'm collecting both from the Elastic agent on the box, as I mentioned, as well as the firewall logs that are coming in from pfSense. Now, a nice thing about the endpoint logs, as you can see, there are process names associated with those. So anytime something on my network initiates a network connection, it logs it for me. I also have these process ancestry hashes, and we'll come back to those later on, but those give me a hierarchy of where that process came from, what kicked it off, where its working directory is, and so on. Okay, now I'm looking at some process data here. You can see over on the right, I've got some Windows usernames. And then I've got the process names. So if I deploy this in my environment, I'm able to get very granular process execution data across the entire enterprise. I can see what accounts on what endpoints are executing exactly what processes. If I see one that looks suspicious, I can pivot into this process info dashboard. It uses that entity ID that I mentioned earlier, the one that's got all the ancestry data in it. And then down here you'll see, okay, well that process executed, it loaded the following DLLs, it caused the following file items to happen, updated the following registry keys, etc. All of that stuff gets logged and then put in that Elasticsearch database on the back end. Here we're looking at file events. This is very similar, except instead of process information, obviously it's file information. So if something is written to a file system anywhere in my enterprise, I can see who wrote it, I can see when they wrote it, I can see if they overwrote or renamed something, I can see what process wrote it, and so on. So that right there in the middle where it says process name, that's a list of all the processes in my environment that are conducting any sort of file activities. Now think about how helpful it would be to be able to see every file activity happening in your environment that was happening in, I don't know, C/user/public, right? Or anywhere else that malware tends to get staged, C/Windows/temp. You can dig in and find all that stuff. And again, it doesn't necessarily have to be Elastic agent that's doing it. You can pull this data from whatever endpoint agent you've already got deployed out there. All right, I will fully embarrass myself now and say that I spent a lot of time trying to track down the DWM account. Does anyone know what that is? Okay, that's, what's that? Just to save you all the trouble, that's an internal service principle that's used by Windows for window management. So for doing things like drawing the login screen, right? So when I first started collecting these logs in a previous life, I saw a whole bunch of these DWM accounts all over my network, and I was convinced we were completely compromised. Nope, just undocumented Microsoft stuff. Thanks, guys. All right. And also, as part of that Elasticsearch ingestion pipeline that we talked about, you can also do enrichment. So data coming in can be enriched with things like GeoIP information, threat intelligence feeds. A lot of this stuff can be pretty easily implemented via Elasticsearch. So if you've got something like a MISP instance or anomaly or alien vault, something like that that you're using for threat intel, you can use that to modify or color the data as it's coming in. This is a specific pfSense dashboard that we include by default. Shows you all your blocks, all your passes, all your DHCP information, etc. All All right, I think that's the end for dashboards. All right, so Hunt, as I mentioned, is more of our investigation platform. The idea is to allow an analyst to very quickly query and dissect and analyze data that's been collected in that Elasticsearch backend. So everything is organized by the module and the data set. So in this case, we're looking at endpoint module, endpoint events file data set. So we're looking at all of the processes that have performed file activities. We add one group by, and now we can see these are all of the processes in my environment that have executed a file activity of any kind and how many times they've done it. So this gives us a really easy way to quickly stack and analyze this stuff. All the dashboard visualizations are there. If we want pie charts, we can do pie charts. We can do bar charts. We can do Sankeys. I think I talked ahead of myself. Come on, you can do it. The basic idea here is, again, we're collecting all of this stuff on the back end so that it's really easy to report on as an analyst. If I want to go in there and say, you know what, I want to know everything, every place on my network that an executable with this particular hash that I just got from my ISAC has executed, we can do that because we're collecting all of this data. All right, now we're getting into some network stuff. So this is also telemetry data that's collected via the Elastic Agent. If you prefer, you can collect this via Sysmon or something. But the particular functionality that I'm looking at here is DNS lookups. So now I can look and see every endpoint in my environment that's making a DNS query and what it's looking for, right? How many times have you been doing an investigation and you find something in your DNS logs and you're like, wow, that's really weird. I wish I knew what process was making that query. Or even, I really wish I knew what endpoint was making that query because I only see this on the domain controller and there's no source IP affiliated with it. If you're pulling this telemetry data in, you can see exactly what process is making what DNS query at what time, right? So if there's some weird dark web URL or some strange, Bitcoin wallet style URL, you can go in and find that in the endpoint logs rather than having to rely on the network telemetry. And then finally, as I mentioned, this is the Sigma detection stuff. So this is an included rule. We include several thousand rules from a public Sigma repository. And this one's pretty straightforward. It's saying if the command line contains CSVDE-F and also contains .log, so it's just doing some simple string matching, or if it contains .vbs/shell and cscript.exe, either one of those is an indicator of this cloud hopper activity, which probably sounds more fun than it is. In either case, that means that something malicious may be going on. We should evaluate this and further investigate. We can write these Sigma rules for any logs that you bring in. So anything that you ingest, again, becomes a detection opportunity. It's pretty cool when you start thinking about it because if you've got everything in your environment instrumented and everything's bringing logs in, then being able to write an alert for the latest, APT tactic becomes very, very straightforward. All right, one last thing here. So this is the alerts pane, right? These are the alerts that were generated by the Suricata instance running on that pfSense firewall. This is external to Security Onion. This is an external Suricata instance running IDS. If we drill down, we can see that we have 3 alerts for this ET-info request for exe via PowerShell. So what that means, for those of you who are unfamiliar with Suricata, is there's a static signature that says if you identify an exe being downloaded from a PowerShell user agent, raise an alert because that is very suspicious. In this case, they're right to be suspicious because somebody is downloading malice.exe, which seems completely legitimate, from a PowerShell instance here. So it's seeing the user agent is PowerShell, it's seeing there's an exe in the GET request. That's why it's raising an alert. Now this is where Suricata's culpability stops, right? It saw this in the network flow, it's alerting us to it, it's done. But circling back to the community ID we talked about earlier, because that community ID uniquely identifies this network flow, and because we are ingesting endpoint logs that are also going through this community ID generator as part of the enrichment process, we also have endpoint network data. So we can take this Suricata alert, again, generated outside of Security Onion, just sent in via syslog, and use it to pivot into our endpoint process data and see exactly what process generated that particular alert. Now, not a lot of suspense on this one. It was PowerShell. But imagine in a more complicated scenario where you've got a second stage or a dropper coming down, you're able to go into those endpoint logs and see exactly what kicked off that malicious activity. And then when we go down to the bottom here, we can do a process ancestry. And again, using those process ID GUIDs that we saw earlier, you can see those all at the top there where it says entity ID, we can get a full life cycle of all the processes that led to this nefarious traffic, right? So we started with WinLogon, it went to Explorer.exe, which went to PowerShell.exe. We get a full breakdown in time of what exactly caused all of this malicious stuff to happen and what generated that Suricata alert. Again, these are all logs that are being generated outside of Security Onion and just imported in there. All we're doing is ingesting them and providing the tools to pivot between them so that it can help with your investigation. All right. So in conclusion, people think of Security Onion primarily as a network monitoring solution, which is fair. That's a core piece of the functionality and has been from the beginning. But even if you don't want to deploy sensors, even if you don't want to deploy a tap infrastructure or span ports, it's also a very capable log management platform that can ingest all of the stuff you are already producing, right? And make it available for analysis and alerting. Once again, Security Onion is a free and open platform. I'll cover up my shirt. I am not here to sell you anything. But if you want visibility into the logs that you're already generating, if you're struggling with this stuff, and I know a lot of products have ingestion limits and stuff, so you may have, all of your core stuff covered, but you've got firewalls in your branch offices that aren't being ingested. You've got NetFlow data and nowhere to send it. All of that stuff can go to Security Onion. Find a hand-me-down server, get our ISO from GitHub, install it, play around with it, okay? Because this will give you a lot of really good visibility and a lot of really good investigation tools for $0. All right, we are about 45 minutes in, which I think is what I was trying to hit. If you want copies of these slides, they're all on my GitHub there, github.com/infosecgoon. You can email me. You can follow me on Twitter, which I will not call X. And I think we probably have a few minutes for questions. Now, for those of you who haven't seen me speak before, the deal is, you ask me a question, you get an onion. So who's got a question? Good, because I can't throw that far.
Colorblind mode? You have a colorblind mode
For the interface? Yeah, it has a light mode and a dark mode.
but a colorblind.
Specifically a colorblind mode?
Yeah, just because there's a lot of moving parts on there and whatnot, you've got a lot of flow charts, but just particularly curious if you had like a colorblind mode.
Not that I'm aware of it. That's a good suggestion. I'll take it to the devs. Anyone else? Yes.
So if you wanted to get started in like a home lab environment, what would you recommend doing first?
You know what? That segues into something that I wanted to mention anyway, so I should probably give you two onions. So if you are at home and you're running something like OpenSense or PFSense, the easiest thing to do would be start ingesting those First, spin up a Security Onion Manager search node. And you can do that either on old hardware, a desktop from 5 years ago would be more than adequate. Or if you're a giant nerd like me and you have a Proxmox instance at home, you can spin it up in Proxmox. We have all the instructions on our site for that. Point your firewall logs at it, and there's a video on our YouTube channel that walks through that whole process if you're using pfSense or OpenSense, and you get to continue hearing the sultry sound of my voice. And then install the Elastic Agent, which is included as part of the platform, on any endpoints that you want to collect logs from. We have very sane defaults on the Elastic Agent, but if you install it on a Windows machine, for example, it will pull all of the event logs and also all of that telemetry data. So that'll give you some good sort of first step visibility. Starting this week, we released 2.4.110, and one of the features there is greater integration with OpenSense, so you can actually control the rules being run by the Suricata instance in OpenSense from Security Onion, which is pretty cool. I didn't really get into our detections module much, but it is awesome. It's like a central place to manage all of your detection rules of all different types. So that's another video you might want to check out. All right.
When you go to install it, is it running on a
It is a Linux-based appliance. So it runs on Oracle Linux 9 is the base OS. If you have a background in Red Hat Linux, it should feel very familiar. It's a very Red Hat-y sort of distro. But generally speaking, the only time you would need to log into the command line is to do version updates. Everything else is exposed through the web interface now. Or if you want to do something really crazy and esoteric with custom log stash weirdness. But for 98% of users, the only thing that they ever need to SSH in for is to do an update. Dave's got a whole farm. The question was, is it easy to configure for external storage? Could you expand on that a little bit?
So I have a Proxmox instance, but the storage in it, I would have to do some major hardware juggling to increase. But I have a QNAP sitting over there with 30 terabytes available, and I have it point to storage.
You can. So you can use network attached storage as part of the deployment. All of the Elasticsearch tables and all of the Security Onion platform stuff is in /NSM. So you could basically just do an NFS mount to /NSM. That would be fine for a small deployment or a home user. I would caution you, because my VP will kill me if I don't, that if you try to deploy this with storage on a QNAP in a production enterprise environment, you're probably going to run into some throughput issues. But as long as you've got decent connectivity to that endpoint and you're not ingesting a tremendous amount of data, you should be fine. Yeah, that should be more than adequate. We have customers out there who are running, thousands of Elastic agents reporting into the same grid, and it's pretty sweet. So yeah, that I'm sure that would be fine. And if you want more information on that, there's documentation at securityonion.com/docs on how to swap out that NSM drive. So you basically do the regular install and then sort of detach it and attach the new one. Okay. Yes.
I'm running a version 2.3 with my PCs with Sysmon just to gather information.
Okay.
And I'm thinking about rolling out the Elastic Agent. We have Intune machines all over the place. Do you need direct line of sight to the home VM to be able to collect these logs? And it's probably a bit of a stupid question. What would your best recommendation be if I want to try to use the agent in the field for meetings that might not necessarily have direct line of sight to the VM?
Okay, so the question was, if you want to deploy and collect logs from machines that are not locally routable to your Security Onion instance, what do you do, right? So one of our specialized node types is what we call a fleet node. Yep. And what the fleet node does is it acts as a passive receiver and Elastic Agent management node that has no other functions. You can just put that in your DMZ. So if you have users who are remote, who are working from home, and you need to collect logs from them, you can basically just expose those couple of ports to this fleet node. They can send the data over the internet. It's all encrypted in transit. And then that way you don't have to expose your security onion infrastructure. Yep. All right. How's my onion? Okay, I got a couple left. Anybody? Yes.
How robust are like the parsing rules for unique log sources? You mentioned like Proxmox. If I start pumping Proxmox logs in there, does it automatically parse those, or do I have to write custom parsing?
So it's going to depend on the log type, obviously. For lots of common logs, we leverage Elastic integrations, which are pre-built pipelines that come from our friends at Elastic. If you want to do something custom, you can do that. You can write your own pipelines for stuff that's not supported. And that can, again, be done through the web interface, but it requires you writing, grok statements and all that stuff.
Is there a big community that kind of publishes those, or kind of write their own?
I guess big is relative. We do have a fairly active user support forum. So if you do head down that road and you run into problems, you can go to securityonion.com/discuss. That'll take you to our GitHub discussion forum. You can ask questions there. The user community is fairly robust, and also, some of us in support hang out on there and answer questions too. All right, who wants the last onion? Any more questions? What's that? All right. Well, thank you so much for being so attentive. I appreciate it. If you have any questions that pop into your head after this, please feel free to flag me down. Take care. Thanks.